Assignment 1, number 5. We have here 5 decimal numbers that we're to convert to binary. So there's different ways to do this. I like to use the technique by which we subtract successive powers of 2, which I find systematic, relatively easy, and relatively error-free, which is a big plus. So let's see, the first one is 193. So I'll put 193 right there. And now we need to look in this chart on the upper right and find the largest power of 2 that we can subtract from 193 without going negative. And if we look here, we see 2 to the 9th is 512. If we go to 2 to the 10th, it goes over. Nope, that's not right. 193, if we go to the 8th, that's 256. But that's bigger than 193, so that won't work. We need to go down to 2 to the 7th, which is 128. We'll subtract 128, which is 2 to the 7th. We'll write that over here. And if I do that subtraction, I get 65. Bring the 65 down here to the next row. And the biggest power of 2 we can subtract is 64, which is 2 to the 6th, leaving 1. Now, I can subtract 1 from that, and that's always, anything 1 is always a number raised to the 0th power, so 2 to the 0. And it follows that 128 plus 64 plus 1 would equal the original number 183. It has to, because we kept subtracting numbers until we hit 0. Well, 128 plus 64 plus 1 is 2 to the 7th plus 2 to the 6th plus 2 to the 0. Which is 128 plus 64 plus 1, which equals 193. Good? So if we were to write that out as a binary vector, we could say 193 in base 10 equals, let's see, there's 2 to the 7th, 2 to the 6th. There is no 2 to the 5th or the 4th or the 3rd or the 2nd or the 1st, but there's a 2 to the 0. And there it is. That's 193, written in binary in base 2. Let's go to the next page so we'll have space to work the next problem. B. 751. Okay, what's the biggest power of 2 we can subtract from 751? Well, I think that's 512, which is 2 to the 9th. I do that subtraction, we get 239. Bring 239 down here to the next row. The biggest number we can pull out of 239 looks like 2 to the 8th is just a little too big, so we need to go to 2 to the 7th, which is 128. And that subtraction gives us a difference of 111. So we'll put 111 there. And from that, well, we'll go to 2 to the 6th, or 64. And subtract those two, we get 47. Bring the 47 down. We can subtract 32, which is 2 to the 5th. And that gives us 15. Oh boy, 2 to the 4th is 16, isn't it? So we need to go to 2 to the 3rd. Which is 8. gives us 7. And we can go to 2 to the second, which is 4. Gives us 3. From 3, we can subtract 2 to the first, which is 2. And from 1, we can subtract 2 to the 0, which is 1. And we're at 0. So we know that 751 in base 10 equals, let's see, there's 2 to the 9th. There's no 2 to the 8th, but a 2 to the 7th, to the 6th, to the 5th. We don't have a 4th, but there's a 3rd, a 2nd, a 1, and a 0. Right? And that is 751 in base 2. For C, our number is 2007. Here I think we need to go to 2 to the 2 to the 11th is too big. So we'll go to 2 to the 10th. 1024. That's 2 to the 10th. I do that subtraction, I get 983. 983. We can do 512, which is 2 to the 9th. Leaves 471. 471. We can get 2 to the 8th, which is 256. And if we do that subtraction, we get 215. From 215, we can get 2 to the 7th, which is 128. 215 minus 128 is 87. From 87, we can subtract 64, which is 2 to the 6th. And that difference is 23. From 23, we can subtract 16, which is 2 to the 4th. And that difference is 7. Now from 7, we can subtract 4, which is 2 to the 2nd, leaving 3. From 3, we can subtract 2, which is 2 to the 1st. And from 1, we can subtract 1, 2 to the 0. So now we can write 2007 in base 10 equals, let's see, there's 10, 9, 8, 7, 6, no 5, a 4, not a 3, 2, 1, 0. And that is 2007 in base 2. And then finally the big one. Better start at the top for this one, huh? What is 19,450 in base 2? Well, looks like the biggest power of 2 we can take out of that is going to be 2 to the 14th. 16,384. 2 to the 14th. That difference is 3,066. From that, we could subtract 2 to the 11th. 2,048. That difference gives us 1,000 18. From 1018, we can take out 2 to the 9th, or 512. Doing the subtraction, we get 500. I can write neater than that. 506. 506 minus, I'm drawing 5s that are hard to read, aren't I? That's better. From 506, let's subtract 256, which is 2 to the 8th. The difference is 250. 250, we'll take out 2 to the 7th, or 128. That difference is 122. From 122, we can subtract 64, which is 2 to the 6th. And the difference there is 58. From 58, we can subtract 32, which is 2 to the 5th. The difference is 26. From 26, we can subtract 16, which is 2 to the 4th, leaving us 10. From 10, we can subtract 8, which is 2 to the 3rd, leaving us 2. From 2, we can subtract 2, which is 2 to the 1st, and that takes us to 0. Now we can write this number in binary. 19,450 in base 10 will be equal to, let's see, there's a 14, there's no 13 or 12, but there is an 11, there's not a 10, there's a 9, 8, 7, 6, 5, 4, 3, not a 2, there's a 1, not a 0. Boy, that's a nice long number, isn't it? That's it. That's 19,450 in base 2.